One of the most interesting or exciting things that we get to do here at the Eureka Innovation Lab is to really consider what does it mean to anticipate an uncertain future in terms of design method, to spend some time just dreaming about the future or nightmaring about the future, as you may. We like to say that when you look at some of those dystopian films about the future, like the Mad Max series or like Blade Runner, you get a sense that that was not a very well planned future, and a much more organized supply chain is going to be necessary. That we need to design the future a little bit better. And so we imagine what will it mean to make jeans in the year 2050. There's a likelihood of material constraint. There's a likelihood of limited access to labor, but the potential for a breakdown of the global economy that we've come to know over the last 25 years, and a return to highly localized or distributed manufacturing methods. So how does a global brand maintain its equity, maintain its sort of the look and feel that it's known for in a scenario where we might not have a major centralized manufacturing anymore? We take on challenges like that and imagine what design tools would be necessary to accommodate those futures. So in the case of a trucker jacket, it's a known item. It has a very distinct material presence to it. It also has, in the front of it, these two front panels are actually made up of 16 different pattern components. In a potential future where that isn't an option anymore, how would we execute something like a jean jacket without industrial expertise? So this is just one exercise in sort of speculative design, but one way of approaching it would be to actually understand the topography. What signifies jean jacket? It's the arrangement of these pieces. It's the marking on the surface that is the result of wearing and washing these pieces. You get the high-low, the sort of undulating surface because of all these seams. To scan those topographies and create tools like I have behind here, which are they are 3D scans of the topography that are then 3D printed, and you get sort of an impression of the face of the garment, in this case reducing 8 panels down to just 1. But you can see all of the visual signifiers are still there, that it still has a very distinct material presence that says Levi's trucker jacket. And then simply by placing fabrics, limited quantity of fabric on top, and applying a sort of a light scraping or sanding, just running sandpaper over the surface, you can actually transfer the pattern of that jean jacket onto a new fabric. The pattern of the sort of high-low and the abrasion that you've applied transfers the sort of the presence, the impression or the ghost of the jean, or jean jacket in this case, onto a new panel that is rather simply manufactured with just a shoulder seam, side seam, and an arm seam. You've reduced much of the complexity of manufacturing. You've reduced the materials used. You've reduced the time it takes to make it, and you removed the industrial complexity, because this can all be made now on a very simple sewing machine. And it's one example. It's not necessarily going to market like this, but it's an example of how we can use this facility and sort of deep reconsideration of our design process as a potential to future-proof our supply chain and anticipate sort of the unexpected deviations from norm that will be the future.